Hello everyone and welcome back. Today we're tackling a LeetCode problem called count partitions with even sum difference. This is a really interesting one because, like many great interview questions, it starts with a simple idea that you can solve logically, but ends with a clever mathematical shortcut that makes the solution incredibly fast. We're going to break down both ways to solve it, step by step. First, let's understand exactly what we're being asked to do. We are given a list of integers, let's call it nums. We need to partition or split this list into two separate non-empty parts, a left side and a right side. We do this by picking an index, which we'll call I. The split happens right after I. Our goal is to count how many of these splits result in a very specific condition. The difference between the sum of the left part and the sum of the right part must be an even number. Let's walk through the first example to see how this works in practice. We have the list 10, 10, 3, 7, 6. First, imagine we split the list right after the first 10. The left side has a sum of 10. The right side is 10 plus 3 plus 7 plus 6, which is 26. The difference is 10 minus 26, giving us negative 16. Is that even? Yes, it is. So that's one valid partition. Next, we move our split point one step to the right. Now the left side is 10 plus 10, which is 20. The right side is 16. The difference is 4. That's also even. So that's our second valid partition. We keep doing this for every possible split point. In this example, it turns out that 4 out of the possible splits satisfy our condition. Just a quick heads up before we dive into the logic. I'll be using Python to demonstrate the concepts and the code. But if you're a Java, C++, or JavaScript developer, don't worry, I've included full solutions for those languages at the very end of the video, so stick around for those. Now let's talk about the first approach. We can call this simulation. It's the most intuitive way to solve the problem. We just do exactly what the problem description says. We loop through the array from the start up to the second to last element. At each step we calculate the sum of the numbers on the left and the sum of the numbers on the right. Then we subtract them and check if the result is even. To make this efficient, instead of adding up all the numbers from scratch every time, we can calculate the total underscore sum first. Then as we move our split point to the right, we just add the current number to our left underscore sum, and the right underscore sum is simply the total underscore sum minus the left underscore sum. Okay, we've talked about the big picture and the logic. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first. And don't worry, after that, we'll walk through the most important sections together. Here is the complete code for the simulation approach. We start by calculating the total sum of the list. Then we initialize our running sum for the left side and our counter. We loop through the array, updating our sums and checking the condition at each step. If the difference is even, we increment our count. Finally, we return the total count. Let's zoom in on the loop because this is where the work happens. Notice the range. We stop at n-1. This is important because the right subarray cannot be empty. So the last valid split is right before the very last element. Inside the loop, we simply add the current number to left underscore sum. We find right underscore sum by subtracting left underscore sum from the total underscore sum. Then, we use the modulo operator to check if the difference is divisible by 2. If it returns 0, we found a valid partition. Now let's look at the second method, which the editorial calls approach mathematics. This one uses a really neat mathematical trick to solve the problem in constant time, practically instantly. Here's the intuition. Let's do some algebra. We know that the left sum plus the right sum equals the total sum. This means the right sum is just total sum minus left sum. We are looking for the difference, which is left sum minus right sum. If we substitute our equation for right sum, we get difference equals left sum minus quantity total minus left sum. Simplifying that, we get difference equals 2 times the left sum minus the total sum. Here is the magic part. 2 times any integer is always an even number. So we have an even number minus the total sum. This means whether the difference is even or odd depends entirely on the total sum. The specific split doesn't even matter. So following that logic, we have two simple cases. Case 1. If the total sum of the array is even, then subtracting it from 2 times left sum will always result in an even number. This means every single possible partition is valid. Since there are n-1 possible places to cut the array, the answer is just the length of the array, -1. Case 2. If the total sum is odd, then subtracting it from an even number will always result in an odd number. This means no partition will ever have an even difference. The answer is simply 0, and here's the code for that mathematical approach. It is incredibly concise. We calculate the total sum. If that sum is divisible by 2, we return the total number of possible cuts, which is the length of nums minus 1. Otherwise, we return 0. That's it. So how fast are these solutions? For the mathematical approach, the time complexity is big O of n. Even though the logic is instant, we still have to iterate through the list once to calculate the total sum. For space complexity, it is big O of 1, or constant space. We are only storing a single variable for the sum, regardless of how large the input list is. This is as efficient as it gets. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. Hopefully seeing it in a few different languages helps solidify the concepts. Alright, before we wrap up, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily LeetCode problem. You know the drill. So I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with a little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now, down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now while it's all free are yours to keep and use forever. So, it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more LeetCode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the Playlist tab and find a playlist that fits your goals. Also, if you're looking for even more LeetCode problems beyond the daily challenge, I've started a second channel called LeetCode Unlocked. It's where I'll be posting solutions to a ton of other problems. So if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this LeetCode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use and a few other good options. Using those links doesn't cost you anything extra but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.